we're here to talk about the just endless number of issues that exist right now for DFIR teams. Even some of the best in the world still struggle with the issues that I'm about to talk about. But I'm not here just to describe the issues that most of you are probably well aware of. I'm here to say that the solution exists now. Sadly, a lot of the solutions and the tools that I'm going to show you don't have marketing budgets, so you might not even know that they exist. The methodologies around those tools you might not be as familiar with. So that's the goal here, is to share some of this. Because Whitney and I have a lot of experience in not only doing security operations, incident response, digital forensics, but scaling it. That's one of the things that I think we have a really unique perspective in. So that's what we're trying to capture here in this talk. So by way of introduction, so my name is Eric Capuano. I've been in information security for, give or take, 15 years, but 15 very dense, very action-packed years. Started my career in the United States Air Force as a cyber warfare operator, and then very quickly started to kind of outgrow the limitations of the federal bureaucracy around the things that we do. So started exercising my skill set in the private sector, supporting also local government, and then moving into actually building a security operations company with Whitney. So she's my partner, my wife, my colleague, my co-founder. So Whitney and I are very much, our introductions are going to be very similar. But we started a company in 2018 called Recon InfoSec, a small managed detection response provider based out of Austin, Texas. So we have a first-hand experience with having to not only do world-class security operations, but to be able to scale it globally with dozens and dozens of very unique and very specific types of environments. A couple other things that I do, because I'm such a nerd and I'm very passionate about this line of work, is I teach it every opportunity I get. I've been a SANS instructor for about 7 years now, but I also run, Whitney and I both run trainings at Black Hat, Wild West Hack Fest, many different B-sides events, and honestly, anywhere that we are given the opportunity to run a training, we take it. We're actually flying from here to Gdynia, Poland, for ZEEFCon next week. Anybody here going to ZEEFCon by chance? No? Okay, excellent, excellent. So we'll be running a 2-day Velociraptor threat hunt workshop there. So we're trainers, we're practitioners, we're nerds. So we feel very welcome here with most of you. But that's enough about me. I'll go ahead and hand it over to Whitney.
I'm Whitney Champion. I'm very nervous to be here right now. So as Eric mentioned, there's a lot of overlap in our careers over the last several years. But prior to that, I found the security space probably 20-some years ago by happenstance. I was in college and I was running a web server out of my closet, and it got hacked, and I realized I should probably learn how to do this better. So let's go figure that out. So found Linux, I fell down the security rabbit hole, and now we're here. So after college, I started out working for the government as a security analyst for a little bit, and I did a lot of cool projects, learned a lot of cool things, in a lot of very boring rooms with no sunshine and no windows. So I realized that was not the way I wanted to go. And I found the startup life, and we started our journeys together, and now here we are. So a lot of my focus the last several years has been around security infrastructure, automation, and orchestration. So I have a lot of fun building and brainstorming tools that not only make our jobs easier, but allow us to be more effective at our jobs. So I think that's why we're here today.
Awesome. Okay, so let's get into the problem statement, which I think most of you, especially if you're in incident response today, you're going to be very familiar with some of these concepts. But what's wrong with IR today? Why are we still lagging behind? Well, there's a lot, to be honest with you. There's a lot of issues, but I'll try to summarize at least what I would consider the top 3 that are getting in our way. Right? And the first one here is the fact that every IR team I've ever worked with or been a part of had some bespoke, very custom, very unique approach to IR. And sometimes that's a good thing. Most of the time, it's not, right? Because it's some collection of random scripts that some guy wrote 6 years ago. Nobody else understands how it works, right? So the problem is they're still using duct tape and bubble gum in order to do IR. But it works. most of the time. But the problem is there's inefficiencies galore, right, with this process. I've got a couple like quotes up here that you might have heard, right? Like, for instance, if you go to a team of IR folks, ask 5 of them how they do IR, you're going to get 7 different answers, right? Because they all have their own idea, their own approach, their own methodology. And again, sometimes that's a good thing, but most of the time it's not. Because generally there's one right answer, but it's a summary of the best thinking of all the seasoned practitioners on a team. I know the best way to do a triage. You know the best way to do processing of forensic artifacts. Okay, well, let's put these things together and just get overall better. Also, you deal with things like legacy approaches, like using Excel to look at timelines. I mean, it works. We did it a lot back in the early 2000s, but there are better ways. Much better ways. So again, I won't go through each and every one of these. It's really just here to illustrate just the things you hear everywhere you go. We're stuck on the old ways of doing things, and that's holding us back. It doesn't scale. It's not repeatable. It's not reliable. The other thing that I see quite often is heavy dependence on third-party tooling. Now, I'm specifically talking about commercial third-party tooling. And what I hear most often from IR folks is, well, yeah, I can do a great IR only if I have CrowdStrike, or only if I have SentinelOne, all right, or whatever top-shelf EDR, SIEM, product that you have. Okay, that's great, but you're not really doing IR, you're operating that tool now. So what happens if you go into an IR and that tool is not available? It's not reliable, it's not functioning. And it's hilarious that this one's coming up for me because this just happened to a team that I'm familiar with last week. Big IR. Well, the tool was there, they couldn't get access to it. So they wasted many hours not responding to the incident because they couldn't get into the tool that they needed in order to do it. So decoupling ourselves from whatever crutch we lean on and instead being holistic practitioners means it doesn't matter what tool I have. I can do it, right? Matter of fact, I don't even need your expensive commercial EDR because my favorite and most effective tool is free. I'm going to share that one with you here in just a few. But another thing that absolutely drives me crazy is when you're dealing with these commercial paid solutions is, well, what happens when you're in the situation where the CIO, CISO, whomever made the decision to only put the EDR on 40% of the environment because it's expensive? Well, that's okay. We'll just deploy it when we need it, right? Okay, but now I've got to call a sales rep and say, hey, I need another 1,000 licenses like now. Okay, well, we'll send some contracts. Okay, not a situation I want to be in, right? I don't want to have to go to the vending machine to get the fire extinguisher to put out a fire, right? I just need it on hand. So that's one of the other issues that we see. And of course, there's so many others. Like, there's a SIEM, but not all the data's in the SIEM because Splunk's expensive. Yeah. Oh, I should probably watch what I say. They're here, aren't they? Okay. Splunk's good. It's good. All right. Now, another one, and this is one that I'd like to say is getting better, but it really depends on where you go. But it's the dependency on other teams. Okay, so maybe you have a great IR team. Maybe you have a great SOC, but you don't have control of the firewalls, maybe, right? That's some network engineering team somewhere in IT. So what happens if I'm in a fast and furious fight with a threat actor in an environment, and I've collected up all the network-based IOCs? Well, I'm ready to start taking, remediative action. But now I have to submit a ticket to the IT team. And they work on different hours. They work on different SLAs. My emergency is not their emergency, right? And so removing any dependency, removing any bottlenecks to the speed that I need to move, because the threat actor is already 16 hours ahead of me, right? I cannot afford to lose any additional time by having to depend on other people who are not moving at the same speed that I am, right? So again, just summarizing some, there's obviously countless other examples of things that get in our way, but these are the ones that I see most commonly and the ones that we have had great success with solving. But I couldn't not use this GIF because it's basically the same concept of the Jurassic Park scene, right? Where the park is coming undone, the dinosaurs are getting out, and they're trying to fix it, but they can't fix it because the only guy that can has gone rogue, right? So they're trying to, put the velociraptors back in the pen, and IT once again doing what IT does. I kid, IT is obviously the glue that holds all these things together, but I don't want to be at their mercy in an emergency. So the next thing is not being completely honest with ourselves about how efficient we are. Most of us have the academic knowledge. If you're in IR, I have no doubt you've seen this diagram before, right? This is the 6-step pick-roll process that a lot of us like to use. There's others like it, but this is one of my favorites. Okay, so we understand academically how IR should flow, right? We know that we're in the preparation phase. Right here, as we sit listening to a talk, we're preparing. If we're in the incident response field, we're getting smarter, we're getting better, we're learning about new techniques, et cetera. But really, where most of us spend our time, when the thing goes boom, we spend it in these 3 steps right here. That's where most of the actual hard work happens during an incident. Okay, but we're familiar with the concept, but how efficient are we at it, right? And that's the thing that a lot of folks don't want to talk about. Because when you really get down into it, it's like, well, I don't know, we take about 14 to 48 hours to do that part. Or sometimes a week to do that part. Okay, well, in the case of a ransomware event, you have minutes or hours. So if you're not measuring the performance of your incident response process, well, how do you know if you're getting better at it or not, right? So that's the other key here that I want to emphasize. And like I said, so even though of the 6 steps in Pickerel, really during an IR, we only have to worry about these 3 right here. Those are the hardest ones. Those are the ones that take the most time. Identifying the issue, but then digging in, scoping it, trying to understand how big it is, how widespread it is, where's the threat actor, where are the persistence mechanisms, all those investigative questions that we must answer. Because eradication, not an option until you've fully figured out the scope of the breach. But if your tooling is holding you back, if other business units are holding you back from answering those questions quickly, well, then you're just pushing that eradication step out further and further and further. And I don't know if you follow the trends, but Mandiant, the M-Trends report, which has been coming out since like 2011, they report this concept of dwell time, right? The amount of time a threat actor, on average, is observed inside environments before they're detected. The number's been going down a lot. I think it's down to something like 11 days as of the last report. But one of the major drivers that's taken it from over 400 days to 11, it's not that blue teams are just getting that much better. It's that threat actors are moving that much faster because they know that the clock is ticking. So they're not dwelling like they used to. They're getting in, they're wiping your backups, and then they're destroying the environment, or they're exfilling the thing, or they're doing the thing. So the point I'm making is they are moving faster. So if you're not, it's not going to be a good time, right? So I'm just trying to emphasize the importance of speed here. Because to visualize this, say you've got your standard textbook attack chain up here. Well, from our perspective, you know, the attack chain starts here. That doesn't mean that's where the attack started. That means that's where we first became aware of it. We've identified, hey, we've got suspicious PowerShell running on one of our production web servers. Okay, well, we've got to start to wrap our arms around that. You know, how bad is it? Is it on this one system? Is it on many others? That's our scoping containment. And so generally, most often, you're here for a fairly long period of time. That's in that pick-and-roll process where we're iterating and iterating and iterating. And the reality is, this is where we want to be. That's where your business wants you to be. That's where your boss wants you to be. Just get rid of the problem, right? Kick them out, re-image the box, whatever you got to do. Just make this problem go away. But the reality is you can't shortcut. You can't fast track to the eradication. If you do, you play this endless game of whack-a-mole. Right? So the point is, this part right here is the most critical to make sure you can actually do a full eradication. You have to understand how big the problem is before you can solve it. So how long does it take you on average to get from identification to eradication? Because if you're measuring that in days right now, you are way behind the curve. Because the reality is, if you're dealing with these hyper-aggressive, fast-moving threat actors, which most of them are now, well, they've got the head start, right? They're pulling the trigger in minutes, and best case, hours. But most teams are still struggling to get here. It's taking them days, if not weeks. So, all right, I think I've made it clear that we suck at IR sometimes, right? But that's okay, because we've got solutions. So there is a solution or a combination of solutions that we have found great success with in solving every single one of those issues. So it's going to cost you a lot of money. We're here to pitch the magic to you, but I'm just kidding, because everything we're about to show you is free. Sometimes that is the coolest part about this industry is that the best things are often free. The problem is you don't hear about them because they don't have marketing budgets. They don't run booths at conferences. So let's start with a couple of the technical pieces of this, right? Some of the technical pieces that are slowing us down. It is this fallacy, this misconception, this old school habit of thinking that anytime I do IR, forensics, I need full disk images of everything, right? Wrong. Now, for the few of you maybe in the room that work in law enforcement or you do criminal investigations, that kind of stuff, you already know what your requirements are. I'm not talking to you. I'm talking to folks that are embedded inside of enterprise organizations, folks that are doing breach investigations, where, let's be honest, you're not going to court. You're not going to go and testify and prosecute some North Korean threat actor. So at the end of the day, I do not need to abide by the ancient way of doing forensics where I'm taking full disk images of 2 terabyte systems. Because that alone is going to increase the gap between you and the threat actor by days. By holding yourself to this artificial requirement that I need full disk images. It's simply not the case. There are a few rare situations where I say, well, you might want a full disk image. If, for instance, you're dealing with anti-forensics, which the last talk was on anti-forensics, right? So sure, there are scenarios where full disk sometimes helps. I'm going to tell you right now, I can count on one finger the number of times I've needed a full disk in the last 5 years. So the real answer here is modernize so that you're not adding artificial constraints because you're adhering to something that doesn't even make sense for your specific function, your role. And it's one of my favorite ways of thinking about it is apply Pareto's principle to it, right? Because generally, that 2 terabyte disk that you would have made a 8-hour bit-by-bit copy of, turns out there's probably only about 4 to 5 gigs worth of critically important data on that disk for you. The forensic data, the things that we already know we need, registry hives, event logs, prefetch, all that good stuff, yeah, that's like this much stuff. So why would I need this much data to get this much stuff off of it? So the main driver in speeding up at least the initial phase of incident response is migrating to what we call triage acquisition, moving from full disk to triage. And triage simply means instead of taking the full 2 terabyte disk, I don't even need 90% of that data, I'm just going to get the stuff I care about. Well, that kind of implies, though, that you know what stuff you care about. And that's a long list of things. The good news is you don't even need to think about it anymore. Triage acquisitions are so common, so popular, this is the way it's done, that you have multiple tools ready to go, free tools that know exactly where those files are. You can extend it, customize it, make it do whatever you want, but the point is, this is the way. So triage acquisition, great, got it. That's not actually rocket science, but it's how we start to move fast. So the first tool I want to share with you, and I'm sure many of you have probably at least heard of it, I'm sure several of you use it, one of the coolest tools to hit DFIR in many, many, many years is a tool called Velociraptor. It was created by a former Googler by the name of Mike Cohen. He's an Australian software engineer. And Mike originally was the architect behind GRR, Google Rapid Response. And he realized some of the limitations, some of the issues with GRR. He's like, okay, this thing is powerful, but unless you have like 4 full-time DevOps people, don't even think about it. It was complex. It was difficult to maintain. So he said, I'm going to do this differently. And so he started work on Velociraptor and basically took all the best parts of GRR, left all the things that people didn't like, and he created one of the most powerful yet easy to use digital forensics incident response tools that's ever existed, and it is free, and it is open source. Now, some years ago, Rapid7 realized, ooh, this is hot. We want this. And they acquired him and the project. But I will say Rapid7's got a pretty good history with maintaining open source tooling, like Meterpreter or Metasploit and that kind of stuff. And they've made good on their promise to Mike that we're going to keep this thing open source and we're going to actually add resources to help you continue building and supporting it. And so it's only thrived since the Rapid7 acquisition. So Velociraptor, I could spend the next 3 hours just talking about how awesome it is. Obviously, I don't have time for that, so I'll just tell you this. This is my go-to triage acquisition tool because it is wicked fast, it is scalable, it has a client-server architecture, so I can pull triage acquisitions from an airplane, from systems that are on the other side of the world. And it's going to work, it's going to be reliable. Furthermore, if you really want to get into it, Velociraptor doesn't even need a triage acquisition because it can do forensic data parsing on the box itself and just return the post-processed output of those artifacts, which oftentimes is actually really what I need. But if I need the triage acquisitions, Velociraptor will take them. It'll run on all major operating systems, Mac, Windows, Linux. It is fast, it is performative, it is secure, it is extremely powerful. Because I can use Velociraptor from A to Z of an entire IR, from the triage acquisitions to knife fighting with an adversary. So you name it, it can do it. And yes, it's more powerful than your really expensive EDR tool. But it has a different set of skills, though. I will say it's not a replacement for your EDR, but it is, in some ways, much more powerful. It's got a fairly intuitive, easy-to-use web interface. You stand this thing up, which, by the way, you can deploy Velociraptor in about 5 minutes. I don't care if you have 50 systems or 15,000. 5 minutes, you'll have this thing rolled out. Both the server and the endpoint agent are single binary. So you could stand up this server with one command. No complicated apt-get install nonsense. It's one command, boom, you have a server. And you take that binary and deploy it to your endpoints, and now you've got agents. And now I can set up hunts against all those endpoints, whether I'm just simply looking for an individual IOC, a specific artifact, or I'm running triage acquisitions on 500 systems. Okay, push the button, go. It's going to happen. It's going to work, and it's going to do great things. So one of the ways we approach this is when we know we have an IR, we use the labeling system in Velociraptor. So we just slap a label on the box. Right there in the UI, we say, this box compromised. That kicks off automations on the back end that say, oh, okay, well, if it's compromised, then let's take triage acquisitions. So it just basically starts to speed up the process. Any analyst on the team can go in and apply that label, and it's going to immediately kick into action all the things that we know are our best practices. Take the triage, send it off for processing, et cetera, et cetera. You're looking at me like, oh, time? Oh, are you kidding me?
It happened fast.
Oh my gosh. Okay, I'm going to speed up. I'm so sorry. What's our cutoff? What's our drop dead? Are we at it? No. Okay, you scared me. Okay. Whew. That look, you scared me. Okay. All right. So anyway, I will pick up the pace only because we've got several things I want to talk about. If anybody wants to expand on this stuff, we're happy to hang out and chat. So Velociraptor, it's awesome. It'll run my triage. It's using the Cape open source Cape target files, which if you're familiar with Cape, it's the same thing that powers Cape, which is another triage acquisition tool. Velociraptor does it better, but that's okay. We love Cape too. But yeah, you just set up that triage. You say, here's all the data I want to get. Well, Eric, I don't know what data I want to get. Well, you don't really need to worry about that because you can just use the built-in presets because we know what we want to get and we contribute to those presets. And so you could just pick one of the base sort of target configurations. Say, I want to get all the stuff. Just get all the stuff. Okay, it'll get all the stuff. It's still going to save you a whole ton of time. And if you're curious where the stuff it gets comes from, it's open source. Eric Zimmerman has a GitHub repo called Cape Files. You can go and read in very clear YAML format all of those targets that inform Velociraptor and Cape where all the best forensic data is. What I love about this is it's open source, it's easy to use, so many practitioners contribute to it regularly. The screenshot I chose up here was intentional because it's Whitney's. So we did an incident response some years ago on Manage Engine, and we happened to discover at that time that there's a default location where Manage Engine writes its logs. I didn't know about that before because I never used Manage Engine. Well, now I know because I just did an IR. So we contribute that back to GitHub, and now every practitioner from this day forward that does an IR with Cape or Velociraptor will get Manage Engine logs. It's just cool, right? So we're all bettering ourselves. We're raising the bar collectively by contributing to things like this. Okay, great. So kick it off. Velociraptor goes, gets the data, brings it back. And it's up to you to do what you want to do with it. Now, next tool, Hayabusa. So Hayabusa is a product of Zach Mathis, who's a SANS instructor as well, but he's based out of Japan. He's part of an organization called Yamato Security. Hayabusa is one of the coolest event log parsing tools that's ever existed. There was one before called Chainsaw. This one's faster, this one's better. This fits into the puzzle because when I drop into a customer environment to do an IR, there's like a 95% chance there's no SIEM. There's no place to go and look at alerts. Okay? So how can I get retroactive threat detections when there was nothing in place before I walked in? I'm going to do it with Hayabusa. Because here's the thing. I've already collected all the event logs from every system in about 5 minutes flat. Well, now I'm going to use Hayabusa to analyze all those event logs at scale and get retroactive detections based on a corpus of about 3,500 threat signatures to include Sigma from GitHub Florian Roth and his team, but also Hayabusa has its own detection logic built in, and it is fast. It's written in Rust, multi-threaded. It is incredibly fast, very powerful. So effectively, all you have to do with Hayabusa is aim it at some event logs, right? Wherever those are. Well, if I already did my triage acquisition, that means I've got them all right here. So I run Hayabusa against it. It's going to do some really cool parsing and analyzing, and based on the detections that I've enabled or disabled, and it's going to generate some output files. CSV, JSON, or just send it right into Elasticsearch or Splunk. And now I have a seam retroactive. As far back as those event logs go, I now have detections for those events. So pop it open, find the threats. Cool, right? It's like going back in time and deploying a seam. I'll take it. Now, I'm moving quick for a reason, because we're not even at the best part yet. So Plazo, it's the next piece of our toolkit. Open source tool, one of the most powerful open source forensic tools that's ever existed, because it is basically the kitchen sink of forensic artifact parsing. Another free tool. Written by Christian, I'm not even going to try to, Gudjonsson, I'm sure someone here could probably say it better than I am. He was a Googler at the time when he created Plazo, because he saw a need for a consolidation of forensic artifact parsing. We used to use 47 different tools to process evidence, and he said, what if there was one that could do all of it? And he made it, and now that still rings true today. So take your triage acquisitions, run them through Plazo, generate super timelines of every single thing that's ever happened on that system based on the evidence that you have. Okay, that's pretty cool. I can throw anything. I can throw raw event logs, registry hives, prefetch files. It doesn't matter. It'll parse it. If it's forensically valuable, Plazo knows how to parse it, and it's going to convert it into temporal timelines to show you the most granular bit of detail about what unfolded on a system. So when you're trying to trace threat actor activities, figure out initial access, lateral movement, it's all going to be in that timeline. It's pretty powerful stuff. Again, it's free. Now, time sketch. And yes, these all tie together, so bear with me. I'm not just throwing random tools at you to overwhelm you. All of this is about to tie together. Time sketch is a critical piece to the puzzle. Yet another open source tool. If you've used Elastic, Kibana, and all that good stuff, well, time sketch is that, but built for forensics, built for timeline analysis and collaboration. So what I'm able to do is take all that great stuff I got out of Plazo, send it into time sketch, and have the ability to collaborate with an entire team on those timelines. Let's all look at them together. Let's all annotate what we're seeing. Let's all, dig in and find where the bad guy is. So I can also, for instance, apply Sigma detection rules against those timelines, which is kind of cool, but Hayabusa does it better, faster, stronger. So just bring the Hayabusa outputs into time sketch as well, and now I've got all the timelines and the detections. Graph your logins, graph your visualizations of what's going on across the systems. It's awesome. All right, so that sounds like a lot of work, right? All these free tools, they're only free if you value your time at nothing. So what if we had SOAR for DFIR, right? Automation. Just push a button, deploy it all. That's where the next tool comes. So OpenRelik, and by the way, Time Sketch and OpenRelik, both written by Johan Berggren, who's based right here in Sweden and Stockholm, he created OpenRelik to solve that problem. What if we had an orchestrator, an automator that could do all these things magically? Just like SOAR does for the SOC, we need the same thing for DFIR. It's exactly what OpenRelik is. It's a container-based platform that essentially just Dockerized all the different tools that we use in an IR and just basically sends it through a workflow, just like SOAR playbook. So you can sit there and build out the workflow to do anything that you can imagine. And if there's something you want it to do that it can't, okay, it's a Docker template. Create a new container and then run whatever tool that you want. And you can visually build out that workflow. So I can say, hey, look, if I ever give you a bunch of EVTXs, we're going to send those to Hayabusa. We're going to also send them to log to timeline. And we're going to export those to CSVs and send them to time sketch. It's also got a very large marketplace of other capabilities. So you want to pull down a new tool, a new feature, whether it be Floss or CAPA or whatever forensic tool you like. It might exist. If it doesn't, submit a PR, add it to the marketplace. Cool. This is kind of redundant. It's just saying that one of the other cool things I can do is in OpenRelik have a worker that also will send things to time sketch. So now we're starting to tie them together, right? It's kind of the benefit there. All right. One last thing on OpenRelik is the fact that it's now powered by AI. So if you have seen the magic of using LLMs to add analyst enablement or decision enablement, that's now a feature. So we can start to interact with our forensic data right there inside of OpenRelik using whether it's local AI that you have, local LLMs, or you hook it into Claude or ChatGPT or something like that. And one last thing, and I'm going to shut up because I've been talking way too much. We got to go meet Johan in Stockholm yesterday, so just a little quick. That was a fun adventure. There's Whitney up there showing him the stuff that she's built, which is coming up. So I'm going to go ahead and hand that over to Whitney, because that was a lot. I don't expect that you retained everything I just said to you, but I will show you this. This is how we tie them all together and make this much more accessible, because that's the only problem with all the tools I just shared with you. They exist, but you got to have a little wherewithal, a little bit of DevOps knowledge to deploy them and use them. Well, Whitney is my magician to make that a lot easier, because I need things to be easier. So, all you.
Eric just likes that last slide because he gets to call me a tool in public. That's all it is. So what if we could simply install .sh? Wouldn't that be great? So one of the cool things is all of these tools are already pretty simple in and of themselves. So Eric dove into all of them, but Johan has taken great care to make sure that OpenRelik is easily deployable. Yes, it's like 75 containers, but you can deploy it with one script. Same with TimeSketch, Velociraptor, one binary. All of these things are simple in and of themselves and easy to deploy, but none of them really know how to talk to each other without some fine-tuning and configuration. So we wanted to make this approachable, repeatable, scalable. I don't know if any of you are familiar with any of the talks that Erica and I have done in the past. Back 4 or 5 years ago, we gave a talk on something very similar. It was before OpenRelik was a thing, before it existed, we built a very similar pipeline that was taking triage acquisitions from Velociraptor and getting them into TimeSketch in a very repeatable, scalable manner. So we took it a step further this time. We love OpenRelik. We love what Johan is building with it, and we wanted to integrate that into our pipeline because it's really powerful. It bundles up all of these other tools and makes them stupid simple to use. So what we've done is basically built one pipeline to bring all of these tools together. So it integrates Velociraptor with OpenRelik, which ties up all those workflows for you in a nice little bow and shoves them into TimeSketch. So within minutes, effectively, you can be staring at hundreds, if not thousands, of timelines, depending on your workload. One install script to install it all. You can deploy it on-prem or in cloud, and then the more CPUs you throw at it, the faster it goes. So that's fun. We also built a few Velociraptor artifacts to basically enable this entire flow from start to finish. So you go into Velociraptor, it's going to go watch for those cape triages that you've deployed across your fleet. As Eric mentioned, the cape files goes and collects all of these various pieces and parts that get bundled up into a zip file, and then we send them into OpenRelik to do the processing, and then those get sent into TimeSketch or not, depending on where you actually want them to go. You can configure all of that as you need.
So the coolest part of this, and just to recap, in case it wasn't clear, if you go back one slide, what Whitney has built is specifically the OpenRelik pipeline project. And this was meant to be the bridge to take the best tools, the tools that we live and die by, bring them together into a single bootstrap installation. So you can run this script and have all those tools not only deployed, but they're all directly now integrated. You push a button, magic happens, which is kind of cool, right? Now, for power users and people that have the wherewithal to build their own workflows and automations, just use that as a template. Use it as inspiration. But for those of you that are still using Excel to look at timelines, this would be a good place to start, right? All right. So the cool thing is in our benchmark testing, what we were able to prove out using this workflow is, hey, I pull event logs through Velociraptor. 4 seconds later, I've got Hayabusa CSV timelines ready to go. 4 seconds from the minute I told Velociraptor to go get the event logs, I come back and I've got, the processing time, but I've got timelines and Hayabusa outputs for event logs. Okay, well, what about something a little bit bigger? Oh, I'm sorry, I misspoke. 5 to 30 seconds for Hayabusa, 4 seconds for the collection. My bad. I know, it's a long time though. 4 seconds to collect them, 5 to 30 seconds to process them. Okay, that's fine. And then another 5 to 30 seconds, hey, to send those timelines to TimeSketch. Okay, but let's just add all that up. What are we talking about? A minute. A minute. and now you have the most important part of your investigation, the full picture of what's going on, right? So what would previously have taken us hours and hours, right? We're down to minutes. And great, you want to do that against 100 systems? Those jobs run in parallel. Go ahead. The only limitation there is how much CPU are you throwing at this thing? Because it'll use every core that it has. So we stand this up on some massive EC2 instance when we know we got a big one, a big breach. Okay, throw 32 cores at it. And it's going to rip through that data as fast as it possibly can, and it can handle it, right, in parallel. So go ahead, Whit. Oh, right. Best part.
Yay. I don't know if we have time. Do we have time?
Do we have time?
Do we have time? Yes? Okay. So we recorded a demo just in case the demo gods frowned upon us today. So we have that as a backup, but we're going to try to do it live. So where is your browser?
Yeah. This tab right here has got your stuff. Tabs. I know. That's why I was going to. There you go. Whoops.
That's not it.
Why is it not letting me?
It's not on the screen.
I know. I got to switch it to duplicate. Stop embarrassing me in front of my friends. Okay. There you go.
Yeah. Oh, I got logged out. Nobody look. Oh, yay. All right. Oh, that's fun. You're making me Windows. I don't want a Windows. All right. So, step number 1, make sure our client's there. Cool.
So we're in Velociraptor right now.
Velociraptor,
For anybody unfamiliar.
All right, so typically the way we've done this in the past is we slap labels on any Velociraptor clients that come in just so we know what IR or what customer or whatever they belong to. So in this case, this host belongs to IR1 just because this is a demo. All right, so we are going to go kick off a really stupid simple cape triage collection. I'm not going to do the full thing because those can take a while. I'm just going to go in here and do event logs because that's all I really need for purposes. Event logs. All right, turn that on, make sure it looks good, mash the button, wait a few seconds for this to bring those back, and while it's doing that, I will go over here and show you what it's actually doing in the background. So we've got what are called server event monitoring artifacts configured on Velociraptor, and this is part of what we added to the pipeline. So these are effectively just watching for that cape triage to finish, so it knows when it's done, it goes and zips up all those files, and then says, hey, go point at this API. So all of these are getting kicked off. So we should be able to go over here to OpenRelik, refresh this guy, and we should start seeing, yep, there we go. All right, so Plazo has started. Hayabusa should be following behind it. If you go in here and click on the workflow, you'll see that it has already created this workflow based on the triage file that we uploaded. It's going to pass that on to Plazo or log the timeline, and then it's going to ship that over to TimeSketch for us. So we don't have to touch anything other than kick off a triage, and even that part can be automated, and that'll be the end of it.
And I just want to call out that, so this specific workflow that you see here, identifying the fact that we have event logs, well, we know that generally what we want to do with event logs is we want to super timeline them, and we want to hit them with Hayabusa. Well, you wouldn't even need to come up with that workflow yourself because that's what Whitney's middleware is doing. It's saying, oh, I know what to do with this. I'm going to use this template, this workflow. I'm going to just kick it off, run it for you. But if you want to customize and configure it and have it do other things, you absolutely can. But right out of the box, it's doing probably one of the best things you could do with that data.
And all of this is open source, so you can go modify it however you see fit. Give back, contribute back if you feel like it. It's totally open. So it has generated the Hayabusa timeline. So now it's going to pass that to TimeSketch. If any of you are familiar with Plazo or Hayabusa, Hayabusa is always super fast, and Plazo can tend to take a little while, especially because I am cheap and I only threw 2 cores at the system. So it's going to be running for like half an hour, and I'm not going to keep you all here. But this should have a Hayabusa timeline in it. There it is, right there. So it's already done. And that took, what, less than 5 minutes? So we've got a timeline sitting there staring at us, and then Plazo should be, it'll be done in a little while. The demo, I cut out the waiting part, but typically if we throw 32 cores at this thing, it'd be done by now. So yeah, your mileage may vary depending on your cloud spend and how much you give it. It can take a little bit longer, but we have data.
So all the projects we shared with you are open source, easy to find. The one net new here, the one that we wrote, or the one that Whitney built specifically to power this talk, is on our GitHub as well, which the link was a few slides back. We'll drop the slides. We'll post those on Blue Sky. But yeah, if you want to pull it down and check it out, Digital Defense Institute, OpenRelik-pipeline, it's your 0 to 60. Run a script, have all these tools integrated, ready to go, and this is our favorite approach. So, yeah, happy to answer any questions, but I know we're probably at time. So,
thank you. That was amazing. Those are some really cool tools. I'm sure a lot of our viewers here, participants, will find some good use for them, I think. Do we have any questions in the crowd? Do I see any hands? No hands? Well, you can always find these guys later. You'll be around, I hope.
Yeah, you bet.